Hello Year 11. Today we're doing about acceleration and velocity time graphs. Now the best way to teach this really is for me to give you the equation and just a little bit of information and then let you try a few. So from last lesson we should remember that speed equals distance divided by the time taken. Now really, if I was writing this out properly, this is the change in distance. Here, this is the change in distance compared to how long you took. Now, when we're talking about acceleration, which is another one you need to remember, acceleration is the change in speed. So it's the change in speed divided by the time taken for that change. If I'm to write this as symbols, I'd write it like this. A for acceleration equals change in speed or velocity over the time. Now we'll take this one further and we're going to write it like A equals V minus U over T. We know A equals acceleration, so let's get a different coloured pen and write what each one means. So A equals acceleration, V equals final velocity or final speed, U equals initial speed or velocity, and T equals time. So this here is the easiest way, I think, of writing this equation as a symbol. So I'm going to be using these letters when I'm answering the next questions. Now you know what each letter means. So let's go down a little bit. Right. So what I'd like you to do is I'll read the question out. I'll write down the variables for you on the side, and I'd like you to try and have a go at question 1. So I'd pause the video, have a go at it, and then if you get stuck or once you finished it, unpause it and see how you did. So the question says, what is the acceleration of a car? So I'm going to write straight away A for acceleration is a question mark because they've asked me to calculate that. That starts at rest. Now when it says starts at rest, the initial velocity or the starting velocity has to equal 0. And it reaches a top speed of 50 meters per second. So that is the final velocity, and that's 50 meters per second. It then says it took 25 seconds. So the time taken, 25 seconds. So I'm going to write my equation out again. A equals V minus U divided by T. So you want to pause it, you want to have a quick go, and then I'll do the answer. Right, I'm assuming that you've paused it, you've had a little try, and that you've got your own answer. So let's put the numbers in. Well, A is still a question mark, so I'm just going to leave it as A. So A equals, open my brackets, V is 50, 0 is U. Now if something starts at rest or starts from stationary, it actually makes this equation a lot easier because the change in velocity, if it goes from 0 to 50, the change is just 50, divided by the time taken, which is 25 seconds. So we're left with 50 divided by 25, and that comes out at 2 meters per second squared. And this is your unit. You need to know that this is the unit of acceleration. Now, I'll do question 2. Okay, question 2 is a little bit more complicated. So let's say question 2. A plane starts at rest, okay? So where it says starts at rest, you know the starting velocity equals 0, which makes it a lot easier. Starting velocity, 0. It takes 8 seconds to take off. Well, there's my time. Time equals 8 seconds. It accelerates, oh, they've given me the acceleration here. It accelerates at a constant rate of 10 meters per second squared. So I know that A equals 10 meters per second squared. What is the final takeoff velocity of the aircraft? So they're saying I need to calculate V equals something. Now, this one's a little bit more difficult because I need to rearrange this equation. So, what I'd like you to do is try and rearrange the equation. So pause it, see if you can rearrange this to make V the subject. It'll be good practice for what you do in maths. So pause it now, have a go. I assume you've had a little try. Now, for rearranging, I'll do it over here. So we've got A equals V minus U in brackets over T. I need V equals in this case. I have to end up with V equals something. So I need to get rid of that T. So what do? To both sides of this equation, I multiply by T. And what happens? T divided by T cancels out. So I'm left with A times by T equals V minus U. Now again, I need to get V equals something, so I need to get rid of this U. Well, how do I get rid of a U? I'm going to have to plus a U here, and then I'm going to have to plus a U here. So what happens is that U and that U will cancel out, and I'm left with U plus AT equals V, or I'm going to swap it around, V equals U plus AT. So that is one way that you can do this. There's the equation that I need now, because it has V equals something. Or I can put the numbers into the acceleration equation and rearrange it using that. So I'm going to do that way as well. So I'm going to do a line down the middle. Using the acceleration equation, A equals V minus U over T. And I put the numbers that I've got over here in. A is 10, which equals V minus U, but U is 0, so I'm going to, if I put minus 0 divided by T, which is 8. Now, if you minus 0, it might as well not be there, so I'm going to get rid of that. And I'm going to tidy this up a bit. So I've got 10 equals V divided by 8. Now, I want you to pause again. I want you to try and have a go at getting V equals from either one of these equations. I want you to get an answer for the velocity. So pause it, have a little go quickly. Right. If I wanted to get V on its own, I need V equals something. So I need to get rid of this divided by 8. And how do I get rid of that? I times both sides by 8, right? So that 8 and that 8 cancels. Well, what's 8 times 10? That would be 80. So I know the final velocity is 80 meters per second. Now if you did it this way, you just had to plug the numbers in. So v equals u, well we know u equals 0, plus acceleration, which was 10, times by the time taken, which is 8. So we get u, so let me just close my emails. We get v equals, well 0, but 0, we can just ignore that, right? 10 times 8 is 80. So we come out with the same answer, 2 different ways. Now that we've had a go at both of them, we are going to have a quick go at looking at velocity time graphs, because the first thing you need to understand is this equation here. You need to be able to use this equation here, right, calculating the acceleration, and then you need to be able to apply it to graphs. So let's have a look at these. This is a velocity time graph for a horse and a rider traveling along a straight track. Now notice the graphs that we looked at yesterday. So if I draw a quick one, they were distance time graphs. So if I had a straight line like this and a horizontal line like this and it went down like that, for my distance time graphs, there's 1, 2 and 3. For a distance time graph, you know at 1 the person is walking away, isn't they? Their distance is increasing because it's a straight line. We know this is a constant speed. We know 2 was stationary or stopped. And we know 3 was moving at a constant speed but backwards. Okay, and this was forwards, and this one was backwards. And because of this graph, this person ended up, you see, back at where they started. Velocity time graphs are a little bit different. Here, let's say the velocity is, I don't know, 10 meters per second. Because this is a flat line, I'm going to zoom in a little bit so we can see. Let's magnify it up. Okay. Let's say this is 10 meters per second. Let's say this is this bit here, dot, 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 dot. This is 20, and let's say that this bit there is 25 meters per second. Okay. So I've just put numbers on it, doesn't really matter what the numbers are. Well, what's happening here where this line is horizontal? This person, this horse I should say, is traveling at 10 meters per second all the way along until here. So this person's velocity stays at 10 meters per second. So which one of the boxes will this be? Well, if they are staying at a 10 meters per second, they've got a steady velocity, and because it's the slowest one, let's have a look. They've got galloping, walking, trotting. So walking is the slowest one. Okay, so this is 1. So this horse is walking at a steady velocity. Now, when you get to this point here, we start at 10 meters per second, and then the line goes up, okay, to 20 meters per second. So at 2, if you look here, we started at 10, then we've ended at 20, so this horse was speeding up at section 2. So I'm going to tell you that the next thing is a trot for a horse. So the number 2 here, speeding up into a trot, was the next bit. Well, if we look at this next part of the graph, the green section, so section 3, well, it's at 20 meters per second here, right? And you can see because the line is horizontal, that line, that means that the velocity did not change. This is a constant velocity at 20 meters per second. So this horse is moving at a steady velocity or a constant velocity. So this is 3. Now, Let's try the black pen. So the next section here is section 4. Notice that this is all 2 and 4 are straight lines going up. Okay, they're not curved lines like this, they're completely straight. Now the velocity started at 20 and ended at 25. But it went up in a straight line, so this is a constant acceleration, this is a steady acceleration. Okay, so this is a constant acceleration. Now, so for 4, this is 4 here, speeding up into a gallop. Let's go back to red again. I think you've got the idea by now. Hopefully, for 5, you should know that this is a steady velocity, right? So this one must be 5. And then for 6, you can see the speed goes from 25 and it goes down to 0. So what is this person doing? Or this horse, I should say. This horse is slowing down. Notice how this is different from the distance time graphs. Okay, because if it was flat on a distance time graph, so here the distance, let's say, is 10, they are stood still if the distance stays at 10. And they are only moving if the distance changes. Now, velocity time graphs, you have to be able to sort of understand the difference between the two and make sure you read which type of graph it is. Okay, at the side, if the line is horizontal, they are moving at a constant velocity. The only time they would be stationary or not moving is if the line was along this x-axis here, where their velocity is 0. So there, this point at the end, that is when they've stopped. So, which acceleration was greater? Tick the correct box. Speeding up into a gallop or speeding up into a trot. Now if you look again, let's go. The way you find this out, and I've mislabeled this axis, this should be about 35. Okay. What you've got to do, like before, on a distance time graph, the steeper the slope, the steeper the velocity is, right? On a velocity time graph, the steeper the slope, the quicker the acceleration is. And to me, 4 looks a lot steeper than 2, okay? 2 looks quite shallow, 4 looks a bit more like this, I think. So 4 is steeper, so that means this was 4, and this was 2. 4 was the greatest acceleration. Explain your choice. The line is steeper on the graph, or the gradient was bigger. You'd get more points for saying the gradient was bigger or larger. But if you said that it's steeper, then you would still get everything. It's just better to use terms that you'd use in maths as well. Right. Now, what I want you to have a go at before we start here is so let's see, A, B, and C, D, and E. So let me write them down. A, B, C, D, E. What I want you to do is tell me what is happening at each section, like the previous question where we talked about it being at a constant velocity, or it was accelerating, or it was decelerating. I would like you to go through each one and tell me what is happening at each section. So pause the video, have a little go, or have a little think, I don't mind. Okay. Now, for A, this is an acceleration because you see the velocity starts at 0 and it ends at 12. So they started from stationary and they ended up at 12. So this is an acceleration, but because it is a straight line, this is a constant acceleration. B, if you look at B, you can see they started at 12 meters per second and they ended at 12 meters per second, so they were moving at a constant speed. Now I'm going to be writing constant a lot, but you need to know that if the line is straight, if it is a straight line, it is a constant speed or a constant velocity or a constant acceleration. C, again, this is a constant acceleration. D and E, they're slowing down. That is still an acceleration, but it's, you can either call it, you've got two choices. You can call it a deceleration, or you can call it a negative acceleration. Okay. So D, for me, I'm going to call it a constant negative acceleration. And actually, E is the same as well. Hopefully, from the graph, if I asked you now to find out to tell me, A or C, which one was the greatest acceleration, you should be able to see A is the steeper slope, so A was the greatest acceleration. And between D and E, which one was the quickest deceleration? Or the greatest negative acceleration? And you should know that D is the greatest slope here. This is the greatest slope. So D was the quickest deceleration. Now, what I need you to do, after I've done one example, is I want you to calculate the acceleration at each point. So I'm going to do A up here. Actually, I won't do A because A is easier. I will do C, and then I will do D. So I'm going to do C as an example and D as an example. I'll do C first. So we need this equation, A equals V minus U over T. The end velocity is 15. So V equals 15. The start velocity equals 12. And the time taken is, it's from here to there. So that's 5, 1, 2, 3 seconds. So T equals 3. Let's have a look then. Let's plug my numbers in. A equals 15 minus 12 over 3. What's 15 minus 12? Well, that's 3. That's 3 divided by 3. That equals 1 meter per second squared. Now let's check. I can definitely see that the slope is going up, so this has to be a positive answer, and I can see that my answer here I've got is above 0. It's positive. That's good. So let's have a look at D. We'll do D in green. So D. Again, I'm using the same equation, so I'm not going to rewrite it again. It's just up there. What is my final velocity? Well, my final velocity is 5. Okay, you see that? If I put a dotted line across, dot, 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 dot. That's my final velocity. So my final velocity equals 5. And what's my starting velocity? My starting velocity is 15. You can see the velocity is going down, right? So I know that I have a negative acceleration. How long did this take? Well, I started at 8 seconds and it went to 10 seconds. So that's 1, 2. 2 seconds in total. Okay. So time equals 2. Let's put it into my equation. A equals final velocity, which is 5, minus starting velocity, which is 15, divided by time taken, which was 2. Well, what's 5 minus 15? That equals minus 10 divided by 2, which is going to be minus 5 meters per second squared. Now that is how you would get a negative answer. This is slowing down, so you know if you've got a minus acceleration, you must be slowing down. Okay, so I've done C and D. I'd like you to have a go at A, B, and E. So pause the video, have a quick go. Okay, now we've already done that one there and we've done that one there. So I've asked you to do A, B, and E. So I'm going to write my equation that I'm using up here. A equals V minus U. So remember, this is finishing velocity minus starting velocity divided by time taken. So let's have a look at A. Right, so V, U, and T equals... The starting velocity in A is 0. The final velocity is 12. The time taken is 3 seconds. So let's write the equation. Well, A equals, up here, this equation. Final, well, 12 minus 0 it's going to be. Minus 0 over 3. What's 12 divided by 3? So that's 4. 4 meters per second squared. B. B should be nice and easy because you know the velocity doesn't change, so the acceleration should equal 0. But let's check. V, U, T. What's the initial velocity? It was 12, and the final velocity is 12. Time taken is 2 seconds. So let's put it in. Acceleration equals 12 minus 12 divided by 2, which equals 0 divided by 2. 0 divided by anything equals 0. So there you go. You've got an acceleration of 0. That means that the speed remains constant. So let's do E. Okay, the start. Right, so right again, final velocity, starting velocity, and time taken. Final velocity is going to be 0 because it finishes here. Starting velocity is 5. Time taken is 1, 2, 3, 4, 5 seconds. Okay, so let's put it in. A equals 0 minus 5 divided by 5. Well, 0 minus 5 is minus 5. So this is minus 5 divided by 5. So the acceleration equals minus 1 meters per second squared. And we're done. Okay. Once you've done that and you've had a go at these, then we're finished for the lesson. So finish your notes off, send them over to me, and then we are good.